This example focuses on two events that are independent. It's very important that when two events are independent, we know this is true, but it's only true when A and B are independent events. So that's two events that do not affect each other. So for example, if A has happened, it doesn't change the chance of B happening, and vice versa. So in part A of this example, we are told that A and B are independent, which means we can definitely use this formula. And we've been given the probability of A and the probability of A union B. Part A, the task is to work out the probability of B. So looking at what we know and what we're trying to find out, we've got A union B. We can do something with A intersect B, and it's B that we're trying to work out. So they all form the parts of the addition rule, which is in the formula book. So this rule here is in the Edexcel formula book. Let's put in what we know. A union B has a probability of 0.4. A has a probability of 0.2. The probability of B we don't know. But then for the intersection, A intersect B, using the fact that they are independent, we can turn this into the probability of A, which is 0.2, multiplied by the probability of B, which we don't know. So in this equation, the only thing we don't know is the probability of B, which is good. That means we can work it out. So by collecting like terms, I'm going to take away 0.2 from both sides of the equation. And I'm going to collect like terms on the right-hand side. I've got 1 PB, take away 0.2 PB, which leaves me 0.8 PB. And then dividing both sides by 0.8, we end up with a quarter. So that is the probability of B in this question. Now for part B, the probability that A doesn't happen and B does happen at the same time. Well, if A and B are independent, then A complement is also going to be independent with B as well. So the quickest way of doing this would be to use a slight modification of this result just by using A complement instead of A. So if the chance A doesn't happen, times by the chance that B happens. Let me stress again, this formula here only true when A and B are independent events. So if you don't know they're independent events, don't use this formula. The probability that A doesn't happen is 1 minus the probability that it does happen. And the probability of B we know was a quarter in part A. So it's 0.8 times a quarter, which gives us 0.2. Part B could have also been done by drawing a Venn diagram. So this is an alternative way of doing part B. We know the intersection is going to be A times B. So 0.2 times a quarter, which is 0.05. Then the probability of A, which is everything inside the A circle, is 0.2, which makes this side 0.15. And the probability of B is 0.25, so that makes this part 0.2. I could work out the outside as well if I wanted to, but the question wants the probability that A doesn't happen and B does happen, which is this section. And as you can see, we get the same answer as the previous method, 0.2.